So what is a z-score? So the basics of a z-score is that this is a way to standardize data. And you may say, well, I don't understand what that means or why that's important. Well, think about this. Some examples. If we talk about test scores, let's say that we have 5 different years of scores. So in different semesters. Every semester, every class is going to have a mean and a standard deviation, right? So if I have these of a bunch of different classes, but they're all going to be different. So this semester, so we'll call this semester 1. Semester 2 is also going to have a mean and a standard deviation, but they're different. And so I can't really, it's like when you hear people talking about comparing apples to oranges. So using z-scores is a way to change these, if we call these apples and we call these oranges, z-scores are a way to make these two things into pairs, right? So it's a way for us to say, instead of having different data values, we can talk about them all as the same type of thing. And that could be miles per gallon for different cars, right? You can't really compare a Hummer to a Hyundai Elantra in terms of gas mileage. Those don't even compare. But if we take the data and we turn them all into z-scores, now we are in standardized mode, and it makes sense. Okay? So the basic definition of a z-score is how many standard deviations the data point is from the mean. So if I have a mean of 7 and a standard deviation of 3, then if I have a data point that, let's say, is 10, okay, well, think about this. Let's give ourselves a number line. Here's my mean of 7. One standard deviation to the right would be adding 3 has a value of 10. So because I am 1 standard deviation above the mean, my z-score would be 1. Similarly, let's get rid of that for a second. Let's pretend that we want to talk about a value of 1. Well, again, I have a mean of 7. If I go 1 standard deviation this way, I have to subtract 3. That has a value of 4. If I go 1 more standard deviation, I subtract 3 again, I have a value of 1. So we are now 2 standard deviations below the mean. So my z-score would be negative 2, excuse me. And it's negative because it's below the mean. So a z-score that is positive is above the mean, and a z-score that is negative is below the mean. That's just the basics of it. So there is a calculation, right? There is a formula. Our z-score formula is data value minus the mean over the standard deviation. Depending on how you use your calculator, you might want to put that numerator into parentheses because your calculator will do order of operations, and so it's something to keep in mind. So you can see in this particular problem that we've outlined, the mean is 60, the standard deviation is 2.5. So if we have a data point of 56, what is the z-score? So using this formula, we're always going to start with our data point. Well, our data point is 56 minus the mean of 60 over the standard deviation of 25. Now think about this. If your mean is 60 and your data point is 56, your data point is below the mean. So you know your z-score is going to be negative. So if we go ahead and finish this out, we end up with negative 4 over 2.5. I lost my decimal point there. And we end up with a z-score of negative 1.6. So this means the data value of 56 is 1.6 standard deviations below the mean. And I know it's below the mean because it's negative. And that's kind of just the basics of z-scores.